Every time someone posts about an AI agent failing on a payment task, the same answer rises to the top. Upgrade your model, use a smarter planner, chain of thought will route around it. It's confident, well-intentioned, and categorically wrong. Today, I'm going to show you exactly why, with the actual authentication architecture of payment processors and a steelman of the strongest counterarguments. We'll cover the strongest case for the better model argument, where it breaks down what a correct fix actually requires and what the agent economy looks like once that layer exists. The people saying, upgrade your model, aren't foolish. They're reasoning from a pattern that has worked. Agents failed at task decomposition, better models fix that. Multi-step reasoning, better models fix that. Hallucinated tool parameters, function calling training fix that. So when agents fail at payment execution, the instinct is same category, same fix. The Steelman, a smart enough agent, invokes correct OAuth flows, constructs correct API signatures, manages credential state, routes to lower friction endpoints. Smarter planner, fewer missequenced calls, fewer hallucinated parameters, better error recovery, all true. And a state-of-the-art agent can already write a syntactically perfect Stripe API call. Parameters correct, signature valid, JSON well-formed. This is not a reasoning problem, so why does the transaction still get blocked? Most developers think payment authentication means, does the API call have the right credentials? If yes, transaction proceeds. If no, 401 error. That model is 15 years out of date. Stripe, ADN, Braintree, and equivalents in emerging markets run multi-layer authentication far beyond API key validation. Layer 1 API authentication, the API key is validated. This is where model improvements actually help. Correct key management, OAuth flows, header construction. Layer 2, merchant identity verification. The processor checks whether the account corresponds to a verified business entity, legal name, verified banking institution, tax ID, KYC checked address. An AI agent process, by default, has none of this. The merchant account belongs to the human operator who registered it. Layer 3, behavioral and velocity fraud scoring, real-time scoring on every transaction, frequency, device fingerprint consistency, IP reputation, time of day patterns, merchant category code consistency. Autonomous agents trigger every risk flag. High velocity, no consistent fingerprint, cloud infrastructure IPs, patterns that look nothing like a human-operated merchant. Layer 4, network level verification. For Visa, MasterCard, SWIFT, issuing bank rules, chargeback risk, regulatory compliance checks that require a human identifiable entity on the payment. A better language model improves layer 1. It does nothing, literally nothing, for layers 2, 3, and 4, and those are where agents actually get blocked. This is not a reasoning problem. This is an identity and infrastructure problem. Objection 1. Agents can use the operator's credentials and merchant account. This solves some of the problem but creates 3 new ones. Shared credentials make agent transactions indistinguishable from operator transactions for accounting, audit, and compliance. No clean answer when regulators ask which transactions were agent initiated. If your agent triggers a velocity alert, the entire shared account goes into review, freezing all human-initiated payments, and shared credentials don't scale across multi-agent deployments. Objection 2. Fine-tuned models with payment-specific training will navigate these systems. Fine-tuning helps at the API layer, but addresses agent behavior, not processor policy. The fraud scoring algorithm doesn't care that your agent has read every page of Stripe documentation. It evaluates identity signals attached to the account, not a function of model capability. You can train a model to perfectly understand it needs a verified merchant identity. That understanding doesn't create the verified merchant identity. Objection 3, this is temporary. Processors will update APIs to accept agent-initiated payments natively, maybe eventually, but timeline matters. Processors move on regulatory and risk cycles, not AI development cycles. KYC requirements are set by financial regulators. The authentication layers exist because of fraud liability, regulatory mandates, and banking network rules that took decades to develop. Believing they'll meaningfully unwind in 18 months is a planning liability. The processors will fix it is not a deployment strategy. If the problem is identity and infrastructure, the fix has to operate there. Requirement 1, a wallet with a native payment identity, a payment account recognized as a legitimate payer by processors, tied to a verified entity, purpose-specific for agent transactions, not the operator's personal account. This satisfies processor identity requirements and creates a clean audit trail. Requirement 2, programmable authorization controls. The operator sets parameters at wallet creation, spending limits, approved vendor categories, time windows, transaction caps, and the agent operates within them autonomously. No per-transaction approval. Pre-authorized rails let the agent execute at machine speed while the operator keeps policy control. Requirement 3, stablecoin settlement for cross-currency. Agents pay vendors across countries, AWS regions, international suppliers, API providers in multiple currencies. Cross-border banking adds settlement delay, conversion costs, correspondent banking complications. Stablecoin settlement, USDC or similar, converted at point of need, removes the correspondent banking layer. Requirement 4, real-time transaction observability. Operators need real-time visibility into every transaction, not batch reconciliation. Without it, giving an agent payment authority is like giving an employee a corporate card with no statement. Once this infrastructure exists, the agent automation ceiling moves. Today, any workflow that terminates in a financial transaction requires human intervention, a rate limiter on the entire system. A procurement agent can autonomously identify vendors, request quotes, compare pricing, evaluate contract terms, draft purchase orders, but the moment it needs to execute payment, it hands off to a human, and the handoff takes hours to days. Quoted prices change. Vendors take other buyers. With a properly capitalized agent wallet and pre-authorized limits, the same procurement agent closes the loop autonomously. Quote accepted, payment executed, confirmation logged in seconds. Multiply this across invoice processing, API subscription management, compute procurement, content licensing, contractor payments, logistics. The payment bottleneck is the constraint on autonomy. Remove it, and you get a structurally different picture. Humans set policy, monitor outcomes, handle exceptions. Agents execute within policy in real time at scale. This is the agent economy. It doesn't require AGI or regulatory overhaul. It requires solving the payment layer, a solvable infrastructure problem. I'll be transparent about what we're building at BananaCrystal, payment infrastructure specifically for AI agents. The core product is a currency liquidity pool that lets developers fund an agent wallet with USDC, convert to our stablecoin USDB, and swap or withdraw into any token or local currency the agent's transaction requires. Concretely, a native payment identity not riding on operator credentials, a programmable authorization layer, a stablecoin settlement rail that handles cross-currency vendor payments without correspondent banking, full real-time transaction observability. Every payment logged, attributable, and auditable. The goal is to make every AI agent should have a BananaCrystal wallet feel as obvious as every service should have a database. Recommendations. Step 1. Audit agent workflows for payment dependencies. Every step that terminates in a financial transaction is your current automation ceiling. Step 2. Separate agent payment identity from operator credentials. Step 3. Define authorization parameters before deployment, not after. Step 4. Build for observability from day 1. Every transaction logged with agent ID, vendor, amount, authorization reference, timestamp, trigger. Step 5. Don't plan around processors updating their policies. Build for the architecture that exists today. Bottom line, just use a better model, misidentifies the layer. Payment processors authenticate payers, not prompts. No reasoning improvement changes what a processor sees when an agent attempts a transaction with no verified identity, no behavioral history, no legal entity. The fix is infrastructure, a wallet, a payment identity, programmable authorization, stablecoin settlement, real-time observability, achievable today without waiting for regulatory change or model improvements. If this is useful, subscribe. We publish research on the agent economy and payment infrastructure every week. Thanks for watching. I'll see you in the next one.